all know that our programs and the way that we deliver learning will morph over the coming months. And for many of us, they already have. As we look to the future of technical education and the role that flipped classrooms and virtual skills and simulation and digital learning will play, today's presentation on best practices in distance learning for welding programs is ideal. Our presenter this afternoon is my colleague, Paul Augusta. To our attendees from Michigan, Paul's is a household name. For decades, he owned and served as president of Applied Technology Systems and today leads its successor company, ATS Midwest. Paul's background and experience is so very relevant to our discussion today. Paul's a brilliant business person. He has an intimate understanding of manufacturing technology and also an extensive education background, including holding a master's degree in educational leadership. He's a thought leader who's dedicated his entire career to making sure students and learners of all ages are provided the opportunity to pursue amazing careers in industry. It's my great pleasure today to introduce to you Paul Augusta.
Thank you, Matt, for that introduction. I'd like to begin by providing a context for our presentation. And I started my business career, my professional career as an educator. And in the early 70s, as a student at Michigan State University, I learned about instructional technology in one of our methods classes. And in the 70s, instructional technology was defined by devices like opaque projectors, which projected newspaper clippings and magazine articles onto a display. They had overhead projectors, which I used extensively to teach mathematics and algorithms and algebraic concepts. And the mimeograph machine, which was used to create and reproduce to reproduce tests for ourselves. In the 80s, instructional technology was defined by the microcomputer revolution of the Apple II Plus computer, the Commodore PET, and the TRS-80. These machines would be loaded with drill and kill software that taught basic math facts and a hangman and video, and vocabulary. In the 90s, we saw the introduction of computer-assisted instruction with a mainframe system called Plato, which had content ranging from basic math, reading, science, to pipe fitting and electrical repair, to video discs, which would allow recording of presentations, to microcomputer-based computer instruction, which was the beginnings of what we have today. If you look at today, you now see extensive use of e-learning with interactive content that can be customized for an individual user, to virtual simulations that allow you, a programmer, to work with a virtual CNC, PLC, robotic simulation, program it and have it operate in a virtual environment, have that same code downloaded directly to that machine and operate it. To virtual assessments, where the learner could take an assessment which would determine exactly the things that are needed, the areas that they would need to go over, and take them through that content. So it would prescribe as well as assess. And that's the state of the art of where we are today. Which brings us to the topic of today, welding. And if we look at welding technology, or as it relates to instructional technology, welding is a 150-year-old process that has been taught pretty much the same way throughout its existence. It's taught with an individual instructor talking in the ear of an individual, telling them what they should or should not do. Miller Welding and Miller Electric, I should say, which is the largest weld manufacturer in the world, owning 40% of the market share, and is a $15 billion company, having weld equipment in MIG, in TIG, in stick, and in multi-processes, looked at the world of welding and said, instruction of how to use our equipment should be left to educational institutions. And they stayed pretty much away from it. There was weld equipment, Miller weld equipment in those labs, but it was basically there to validate skills that a person would need when they go into the world of work. But around 2015, Miller made a business decision. They saw that 250,000 welders were needed in the society, and they took it upon themselves to enter into the world of education. And that, like any $15 billion company would do, they were thoughtful about it. They looked around the world, looked at the technologies that were being employed in this environment, and settled on, found a company, a little company in Spain called Seabury, who had a technology for simulation of welding that was a generation removed from anything that was on the was in the current environment. And it was using augmented reality. Any of you that are interested in understanding the differences between virtual reality and augmented reality, I send you to Google, where you'll visit blogs that are gaming blogs that will espouse the virtues of the authenticity of augmented reality, which brings all of the features and functions of welding right to a desktop. What Miller did was to add the Miller Weld helmet with a camera inside that is going to convert these coupons into actual weld units. It uses a Miller weld gun, whether it be a MIG, a TIG, or a stick welder, and it has a variety of coupons, which would allow the learner to test and try out each of these devices independently. Built into the system are all the American Weld Society certification standards for distance, speed, and travel. So these are all built into the system with an assessment tool to evaluate the quality of a weld. And here's an example of it. Oh, sorry, what happened? Here we go. So the system provides feedback to the learner, biofeedback, that tells them whether they are on target with their angle, with their speed, with their distance. And that feedback allows the learner to develop the muscle memory that's required to learn how to weld. Because welding is more than a skill, it's an art form. And it requires that muscle memory, much like a basketball player practices a shot to a certain point so that he or she would be able to shoot it without even looking at the rim. Welding is done in the similar kind of fashion so that you reinforce the skills. The value proposition that Miller put into this system was that it would reduce the amount of time that it would take for a person to become effective as a welder, and it saved on materials. The added benefit in today's society, and given the fact that we are practicing social distancing, is that the learner can operate this independently. The system will record that weld, and the instructor can review it with that student at a distance. Doesn't have to be next to each other, doesn't have to be in that person's ear. This was probably brought home to me most evidently when we were invited to the UAW GM Health and Safety Conference several years ago to show off some of the apprenticeship training program content that we had in mechanical and electrical and tool and die trades. The Miller Augmented Welder was the hit of that conference, with skilled trade people from all different classifications coming up and competing to see who had the best weld. What really drove home the point of how this system operates was when a 28-year-old female labor relations apprentice came up, not ever having touched this machine, received 2 minutes worth of introduction, and laid down a 95, the best weld throughout that conference. What we learned is that from that is that millennials take to this technology directly because it's really just a Nintendo Wii on steroids. It provides all the feedback that they would need. So while our generation or the older generations would look at this and look at it as foreign, they view it as something that's very natural to them. But Miller realized that it was not enough to have a simulation, so they built a something they called LiveArc, which has all the biometrics that the augmented arc has in it, with all the feedback and all the assessments, but it's using a live welder. So they developed these tools and deployed them into the education arena, but they realized it wasn't enough to have skills, that the ability to develop those skills or tools that develop those skills, because the need was for weld instructors. And those weld instructors were retiring at a very alarming rate. So Miller made the decision to take all of the content that they had in a print-based format, the hundreds of pages, and they converted it into an e-learning format. So they organized all the content that they had. They developed a instructional process that had learning objectives at the front, content delivery, and testing at the back side, or assessments at the back side. And they had this organized in open areas. They made the decision that this product should be free. So all of this content is available to any educator, and they deployed it on an LMS system that they built that they called OpenBook. So the content is available, the system is available. All the educational institution has to do is sign up. This has been available for 1.5 years. And our company, ATS Lab Midwest, realized that one of the missing pieces to making this system operate is that there needs to be an administration to the process, that welders and weld instructors are not going to jump into this system. So we took upon ourselves to take a look at all the content that Miller had, and we incorporated it into courses. So we designed a series of courses based on the Miller content and organized them into weld fundamentals, stick welding, MIG welding, and TIG welding. We loaded those courses into the system and began to work with that system. And we are now ready to assist other schools in the implementation of the program. And our goal here today is to introduce you to this system and to offer you our assistance in operating it. So every student, teacher, administrator that enters the Miller portal comes at it at the same point. When you log into the Miller OpenBook, the system will automatically recognize whether you are a teacher, a student, or an administrator. Students administrators have the access, complete access to the system, and they assign teachers to the system. Teachers have access to create courses, to implement courses, to manage users, to manage the instructors and, instruction, and to add questions or content to the system. And of course, learners go through the process, take the assessments, and are graded and recorded. So as a student logs in, they're given, this happens to be the Weld Fundamentals course, and there's a list of 10 modules that they have here. And because there's a learning curve for how to operate this system, Miller has built a series of help. So if you click on the help button up here, it will take you to a help screen, which is contextual. So if you're logging in as a student, here, these are the items that you have available. It's going to navigate you through how to operate within this system. If you're an instructor, your help menu will look differently.
Upon completion of this e-learning series, you will be able to identify the components of a gas metal arc welding system, explain the difference between constant current and constant voltage welding output, and understand duty cycle.
What the system is, what each of the modules does is it provides a list of a scope and a sequence, a course of outline of content that's going to be covered, and then it will go through that content and then ask some questions at the end.
At the completion of this e-learning series, you will be able to identify the components of a gas metal arc welding system, explain the difference between constant current and constant voltage welding output, and understand duty cycle. There are 4 major components that complete a GMAW system. These are a welding power source that supplies the welding or secondary power, a wire feeder to deliver the wire to the weld pool, a shielding gas system to ensure adequate gas coverage, and a MIG gun to bring everything together to make a weld. Gas metal arc welding requires a welding power source that can deliver constant voltage direct current output. Occasionally, the DC CV welding power source may also be called a constant potential or CP welding machine. The CV welding power supply adjusts the voltage as the welder works. Since both.
So as a student completes a module, they're given a series of questions. Miller has built 4 questions into each one of their modules, but has created a facility to allow instructors to add their own questions, so that it's really just set a groundwork and assuming that instructors would enhance the system for their own use. Upon completion, the assessment is scored, and the student is brought back to their main screen where they are given a progress report. When the instructor logs into the system, they're going to do it at the same point, but their view is going to be different. Here, an instructor is given a list of courses that they have either built or have had assigned to them, and courses are organized, the content is organized within, but it is totally customizable by the instructor. There's a help screen for how to use the system. The intent here is to make this as self-sufficient as possible. Here's a list of a course, MIG welding. So this course is started on the 6th of April and has an open end. If you wish to have a course with an end date, that is, you start a term at one date and close it out 6 or 8 or 16 weeks later, you simply close it out. And the content then is deployed, and the instructor is able to view their students, which is listed here below. They can add students. They can invite students to participate. And you have over here the ability to manage your users. And then there's a built-in gradebook, which will keep track of how the student learners have how much they've completed and how they've done. There are tools here built in to allow the learner, or excuse me, allow the instructor to export this data from the system into their own grade book. It's a fairly simple system, so it's going to use either an Excel or a CVS format, and then it has to be imported back. So Miller has designed a system that is totally open, but in that openness creates a lot of uncertainty. And this is where ATS Lab Midwest has made the business decision to incorporate our skills and our knowledge to the system. So we believe that the combination of Miller with their technology, with their knowledge, with their system, and ATS Lab Midwest with their instructional and technical support, that we can provide the best possible solution for welding instruction. ATS Lab Midwest has made the decision to take our technical support team and turn them into LMS experts. We've been working on this over the last several months and are now working with our suppliers, whether it be Miller, whether it be Amatrol, whether it be Quanzer, whether it be LJ Create, that we are going to provide support to our customers to help them implement. Because the key to the success of any technical program, which I've learned over the last 40 years, is that the key to success of a technical program is in its implementation. You have one opportunity to make a good impression, and we want to be able to do that with your learners. With that in mind, the services that ATS Lab Midwest are providing include the review of the program competencies, to compare it with what's in OpenBook and crosswalk it to that content and design a course of sequence that will meet your needs. We will provide ongoing support by administering the site, by managing students, by assigning the courses, helping with reporting, and reviewing both the utilization, completion, and performance. And we're doing that for an annual cost of $1,500 a year. To start with, though, we are offering some scholarships to get this process started. We understand that that we're in the early stages of innovation here. So we are establishing scholarships for existing weld programs with a minimum of 10 students that make a commitment to use at least 20% of the content that's virtually available on Miller OpenBook, that the instructors agree to participate in virtual meetings with other scholarship recipients to share best practices and make suggestions for how to improve the program, and must be willing to share their ideas and their testimonials about the operation of the system. We believe that Miller, with its simulation trainers and its e-learning, have created that has brought, welding into the 21st century. And ATS Lab Midwest is all about securing the American dream through technology and innovation.